So my name is Jack Morelia. I'm the CEO of Claw Industries, and we turn glass bottles into concrete. In order to understand how we do this, we first need to understand two very different industries and their systemic problems. Let's start with the recycling industry. When you place a glass bottle in the recycling bin, it often isn't recycled. Instead, it is broken up and mixed with the smaller pieces of the other recyclable materials, making the glass unusable to make new glass bottles or anything else. So recycling facilities are forced to send the glass to the landfill at a loss. To give you a better idea of what I'm talking about, here's a picture of the waste glass that comes out of a typical recycling facility. As you can see, it's about 80% glass by mass, but the other 20% is every other type of contamination you could think of. I mean, you can see it all right there. And this is very obviously not useful in any modern manufacturing process. So recycling facilities can't sell it and are forced to send all this glass to the landfill at a loss of over $200,000 a year for a typical facility. Now I want to totally switch gears and talk about the concrete industry. To make concrete, you need coarse aggregate, think gravel, fine aggregate, think sand, and cement and water, which form a glue that holds the aggregates together. This is what makes the modern concrete that we all know and love, but there's much more to it than that. Cement is 15% of concrete by weight, but is 75% of concrete by cost. It's by far the highest material cost for a typical concrete manufacturer. So manufacturers have been trying to find ways to reduce these costs for years. The main way they do this is using what's known as a cement replacement. A cement replacement is material that partially replaces the cement in your concrete, making the overall concrete lower cost and adjusting some of the material properties. The common cement replacements out there are fly ash from coal power plants and slag from steel foundries. However, both of these are quickly disappearing from the United States. And in New York, where we're from, both industries are almost entirely gone. This, while switching away from coal power plants is beneficial for the environment in the sense that we're making more sustainable energy generation sources, it's bad for the environment in the sense that when concrete manufacturers can't get it, they are forced to move to 100% cement mixes. For every additional ton of cement they're using, that's 1 ton of CO2 that's released into the atmosphere. This is bad for the environment and bad for their bottom line because they're paying much more for that cement. So how do we solve these problems? At Claw Industries, we take the waste glass from recycling facilities, we put it through our patent pending process and create Pantheon, a partial replacement for cement like fly ash or slag. For recycling facilities, we're able to lower their costs since we're actually getting value from the glass, and we're able to guarantee to them that their glass is actually recycled, which is important to them altruistically as well as for grants that fund these facilities. For concrete facilities using Pantheon, we're able to lower their costs since Pantheon is lower cost than fly ash, slag, or cement, and much more environmentally sustainable since it's 100% recycled material. But most importantly to the concrete manufacturers, Pantheon makes concrete stronger and more chemically resistant, meaning without changing their process, concrete manufacturers can offer their customers an all-around better product at a lower price point. We've proven these enhanced performance properties in the field. For example, we did one test at Barney and Dickinson Concrete. It's a concrete manufacturer near us. And we showed that by replacing the slag they're currently using and comparing the two mixes head to head, that Pantheon actually produces an 11% stronger concrete with the same mix. So without changing anything, they can get 11% stronger concrete with a lower cost material. We've also laid out the costs comparing Pantheon cement and all the other competitive products out there, just so we can look at it on a graph and it makes it more understandable. So as you can see, Pantheon is the only thing lower priced than cement. And this is really where all cement replacements once were when they were started. But now that fly ash and slag are harder to get, the price goes up because supply and demand. And so after us, there's fly ash and slag, and then there's 2 other materials that are also glass pozzolans. However, these are only used in very specialty projects because they're actually very cost constrained. They're too high cost to be used in an everyday mixture, and there's no added benefit other than slightly higher strength. So what happens is concrete manufacturers don't want to use these either because they're so absorbently expensive. We're able to bring all the environmental benefits of recycled glass recycled high performance glass, such as what's on the left here, in our product, since we're using recycled glass, but we're able to get it from the waste stream, which not only allows us to lower our cost, it allows us to get much more glass than the clean glass that's currently available. The reason we're able to use the waste stream and everyone else isn't is because of our patent pending process and technology. This technology is something we invented and hold the patent or the patent pending for. And this allows us to process out that contamination from the recycling facilities and use it in the concrete manufacturing process with no issues, allowing us to lower our costs and increase our volume. So we've worked with many companies to verify that this works for them and helps them with the current problems that are hurting their companies. We've worked with 4 recycling facilities here in New York, as well as across the Northeast, to verify that we can take their waste glass and turn it into Pantheon. And then we've worked with 7 concrete manufacturers across the Northeast in order to show that we can take that waste glass, turn it into Pantheon, and use it in their process with no issues. And we've seen that at all 7 concrete manufacturers we've worked with. We've then gone a step further and worked with engineering companies to receive letters of support. And we've received a letter of support from the New York State DOT, which is the regulating body that will be regulating us once we're at a high volume and operating in government jobs. So once at a full-scale plant, when we're manufacturing Pantheon, we will be taking in 50,000 tons of glass. That will result in over $5.5 million in revenue, and over $900,000 of that will be profit. And this is just one facility that will be operating to service the northeastern of the United States. To get to this point, there's a lot of things that we have to do, and we've already done a lot as well. We've given samples to customers and filed for a patent, as I already said. We've also received ASTM certification and are working towards submitting for New York State DOT certification. We're then going to finish securing funding to begin working on this full time. And then in June of 2021, we will open a pilot plant that will service 2 local concrete facilities and 2 local recycling facilities. This will prove out the process and prove that there is, in fact, a demand for what we are doing. And then in July of 2023, we plan to scale to a full-scale facility, which will be servicing the Northeast, as we already looked at. Well, the other slide, which seems to have an error, is about us. So there's the 3 main founders, myself, Jacob Kumpan, and Tanner Wallace. We are all childhood friends. We grew up together. And we went to college. We decided we wanted to go into business together. So after going through the process and landing on what we do now, we realized that we don't know a lot about business since we're all engineering students. And we certainly don't know all the complexities of concrete chemistry in their entirety. So we brought on a board of advisors to help us in these complex problems. This board of advisors include Jamie and Ashley from the Shipley Center of Innovation at Clarkson University, as well as Dr. P and Dr. Thomas, 2 environmental concrete professors located at Clarkson as well, who are some of the best in the world at understanding the environmental impacts of concrete and the chemistry involved in it. So they're on our board of advisors and helping us get to the goals we want to achieve. So thank you. Do you have any questions?
Really fascinating, Jack. Thank you for sharing. From here, I'll turn it over to our judges for their questions.
Really impressive presentation, team, particularly for self-confessed electrical engineers. I do admire in particular the fact that you recognized areas of gaps in your knowledge and reached out and pulled specialists in. So really commendable. A couple of questions, please. One relates to the quality of the product. Obviously, in manufacturing, one wants to reduce variability. And from one of your earlier slides, you talked about the variability that you have in a key raw material here relative to the recycled glass. Any comments on any risks or concerns related to the variability that comes with that recycled glass in the manufacture of Pantheon? And the second question is the timeline to bring the pilot plant up, assuming that means procuring capital equipment and getting a plant up and running. seemed extremely aggressive. I think it was showing about 6 weeks in the business plan. And I wondered if you were using an outside manufacturing partner or whether you were doing it yourself.
Yeah, so the first thing about the variability in the product, that's a big concern for concrete manufacturers. They obviously want their concrete, when they mix it, they want to come out at the same time every time. They have other things to deal with and their concrete acting differently. So a lot of what the time we spent developing our process is actually verifying that we can consistently get the same results from processing the material. And it was hard, but after a while we are able to do that. We could achieve about 99.5% purity very consistently with like only 1% variability like between different tests. And then so that's a big thing that we've tackled and we believe is part of our advantage as far as our technology. Then as far as developing the manufacturing process, we've already identified the machines we need and we're talking to the people that sell them. We're planning to actually use used equipment, one for cost and two for availability. There's a lot of closed factories in New York and the surrounding states. And so there's actually used industrial suppliers that like buy up these factories and sell them. And so we've been working with those guys to identify the equipment we need. We actually have eyes on several options for what we need to buy. And some of it we've already bought for our prototype process. So to actually get to the next level of scale, it's actually a handful of machines that we've identified and secured funding for. And then also we've done this with a prototype process. We have a pretty good idea of how to do it for a larger process. We believe that we can achieve it in that timeline, although I recognize that it is aggressive.
Great, thank you.
I've done 6 remodels in my life. I've used a lot of concrete foundations. And I also actually have been very involved with the environmental working group for many years. So what's interesting here is that you're taking recycled materials out of what could potentially go into a landfill, but it's polluted recycled materials because you have other materials in it. So when you take this from the recycling facilities, take the glass off their hands, are you purifying it? Are you pulling all those materials out? There's that question. And then the other question is a lot of the pollution that comes from glass is what's emitted when you're making new glass. So when you make your product, when you're doing the melting down and producing for this product that will go into the cement concrete product, what is your air pollution impact?
Yeah, so as far as air pollution, there's almost none. The only air pollution, our process is almost entirely electric. So the air pollution is purely associated with the energy to run those electric machines. A big energy intensive process is grinding. But I believe we've broken it down. The number is like we're about 3% of the CO2 impact, including like all the CO2 from electricity of making a ton of cement. So 3% of the cement carbon footprint.
And you're purifying the glass, you're taking all of the elements out?
Yeah, yes, we're doing that. That's not very carbon intensive. The only byproduct of that is the waste obviously can't be used in the concrete. So the waste removed is landfilled.
Okay, and then what about water? Are you using more, same, or less water than the current solution?
So the current cement manufacturing process doesn't use a ton of water, as far as I'm aware. We do use some water in our process for a variety of things, but not a lot. Like it's not a hugely water intensive process. So I think we use like 5 gallons roughly per ton.
So it's a neutral.
Yeah,
Okay.
it's not very impactful.
Okay.
I've kind of background on both aspects of your business, so I thought this was really interesting to discuss with you guys. I designed and built and then sold a recycling plant. It was mostly for plastic, but the guy I sold it to had a good line. He said, you started out as a recycler and you ended up with a trash plant. And that was kind of the way I felt with how things worked, which was kind of what Ingrid was coming on the the background on the glass coming in, does the supplier pay you to take the glass? And
Yeah,
that's the difference then on the pricing as opposed to going with virgin silica or something along those lines?
yeah. So currently we're paid roughly about $25 a ton to take the waste glass from a MRF, a recycling facility,
Mhm.
and then use it in our process, because otherwise they're going to pay much more than that to send it to the landfill.
Okay, so that's the reason really for using the recycled, and then your process processes, pulverizes, and cleans out any impurities. And that's the cost savings basically that you guys are building in, since you're not bringing in silica.
Yeah, exactly.
Okay, gotcha. And then I've actually been to several cement and concrete factories, which is fun. One of my best friends from college actually has a company that sells different fuel sources, almost exactly what you guys are doing, but instead of doing the input, he does the fuel sources.
Mhm.
Similar model where they get paid to take in tires or turpentine or medical waste or whatever, and then they develop a process to burn it in the kilns. So I can tell you from dealing with those guys is, yeah, consistency is a huge aspect because they are liable for their product for years and years to come on cement. So have you guys thought maybe roads would be better for your process at first as opposed to buildings, or have you looked into those type of things? Or are you really just looking at cement in general and waiting for the market to figure that part out?
Yeah, so our target market is, we're currently, because New York State DOT certifications and certificate like DOT
Mhm.
roads and bridges sort of certifications, no matter where you are, take a long time to go through. These guys obviously don't want to be the first. They don't want to make mistakes. It has to be right. So we're going through that process, but to start making, instead of waiting the 1 to 3 years to get that certification and then start making money, we're targeting the non-DOT, like less regulated ready mix concrete industry. So targeting like the guys making houses, shed pads, that sort of thing to start. And those are lower risk, like you were saying, like
Yeah.
those are lower risk, and they're also more, let's say, they're also more open to saving money. They're more wanting to take the risk because they're doing high volume stuff. And that will give us a portfolio of things to show both the DOTs as well as engineering firms and that sort of stuff. We could say like, hey, like this isn't like a new thing that we don't know what's going to happen. Like this concrete has been in the field for years, and we could point to it and like show them, in a very concrete example, excuse the pun, but like that this works, and nothing's going to happen if you put it in a higher risk project, and then work your way up the ladder from there.
Gotcha. Okay, gotcha. So you guys have thought about those type of things. Okay. Yeah. I mean, I think it looks great. Thanks.
Yeah. Thank you.
Yep.
Judges, any final comments or questions for Jacob or Jack? No.
Great presentation, guys. Excellent.
Thank you.
Yeah, I think that sometimes it's the insides of a business or an infrastructure, an industry that you don't even realize plays such a huge role in our world, and concrete, cement. This is one of them. Some of the largest, most successful companies that I know, and I'm talking billion-dollar businesses, are privately owned, and they are industries that you wouldn't even think of, like the pipes that move water from point A to point B, or this metal piece that goes around an air conditioning unit, and this one company based in Sun Valley actually owns all of the pieces to that. And when I think of this, it's one of these businesses that's a little hidden. It's not necessarily what you normally see in a competition like this or from college students, but it's one of those businesses that's needed. It can be huge, and it can have a great impact on an entire infrastructure. So I commend you for that. I think it's a great opportunity for not only you, but our entire community to better our planet and build at the same time.
Thank you. Yeah, I think it's really fascinating. We actually have a local businessman who invented landfills, like the rubber seals that go in landfills. So I thought that's what came to mind. He became very wealthy just making landfills safer.
I like the logo, by the way. So
Thank
that it
you.
was all of your, the name was your company, all your folks' names is the cloth.
Yeah, sorry for my bad for not changing my background. I just noticed that like halfway through the presentation.
That's okay. Jacob, Jack, thank you so much. It was wonderful learning about claw industries, and I definitely took away something I didn't even know was possible with regards to the concrete and cement industries.